All right, we're on to 6-2, day 2. We're still factoring trinomials. We're going to take a look at some of those harder scenarios so we can practice a little bit more, some of the things that can be more challenging for people. So we're going to pick up where we left off from yesterday on this example 6. And then we're going to look at, or no, actually it's example 5, I think, but the second one. Yep, that's what it is. So it looks like it should say example 5 here. So we're going to look at letter B. So let's go ahead and kind of walk through our process from yesterday. So we have trinomials that we're trying to factor into two binomials. So we're looking for that reverse FOIL, undoing that. And we're looking at where those terms come from. First thing you always check for, though, is there a GCF? Is there something I could pull out of all three of those numbers? A 10 and a 17 and a 3? No like factors there, so there's nothing I can pull out. So I know if it's going to factor with real numbers, it's going to have to do, or with integer values, it's going to have to be these two binomials. So let's start with this first. And again, this is the harder scenario where that leading coefficient is something other than 1. It makes this a little bit more challenging. So we need things that are a product of 10. So a product of 10, I guess I don't need to write the of part. So a product of 10. So what multiplies to give you 10? Well, we got 1 and 10, or 2 and 5. There's really nothing else, so it's going to have to be one of those if it's going to work. And then again, because this is the first, we have that x squared. So in that first position, I know I'm for sure going to have an x. So it's either going to be 1 and 10 or 2 and 5 in front of the x. All right, now the last is the 3. So thank goodness, we love 3. It's a prime number. Do you know what I mean when I say a prime number? Well, prime numbers are things that only have two factors. So there's only one thing that can multiply to get you 3, and that's 1 times 3. We love prime numbers, so we know it's going to have to be that pair. Now let's double check our signs. It's a positive, so that means the signs have to be the same. So the signs have to be the same. It's either a plus times a plus or a minus times a minus. Look at that middle term, also a plus. That means the outsides and the insides add to a positive number, which means they both have to be plus. So I immediately know these are both going to be plus, and I know it has to be a 1 and a 3. So again, like I said, we love prime numbers. It makes life so much easier. So now it's really a matter of just choosing between the 1 and the 10 and the 2 and the 5, and where do we put those? So we're trying to make a 17, so we just need to make a choice. Again, when I multiply with the 10, if I multiply 10 over here with the 3, it's going to be 30. It's going to be pretty big. If I do the 10 here, it's only going to give me 10 plus 3. So I think that's too small. I think we need the 2 and the 5. So let's try it in both ways. So either I can put the 2 with the 1 and the 5 with the 3, or my other option is I can say, no, let's see. I'm going to do it the other way, since I'll keep the 1 the same. The other way would be putting the 5 with the 1 and the 2x with the 3. So those are your two options, and we just have to see which one works. So remember, the outsides plus the insides together have to add to 17. All right, so let's try the first one. So outsides, 2 times 3, that would give you 6x. Insides, 1 times 5 would give you 5x. Add them together, only adds to 11x. That's not big enough. We needed a 17. All right, so let's check this one. Outsides gives you a 15x. Insides gives you another 2x. 15 plus 2, there's your 17 that we were looking for. So the two pairs that we wanted were the 5x plus 1 and the 2x plus 3. So again, I mean, we're trying the possibilities, right? It's a limited list. The biggest issue people run into is if you screw up your arithmetic, right? If you add or subtract wrong, you're not, maybe have tried the pair that works, but you didn't get it to work because you mess up the arithmetic. So be careful with that arithmetic. Be aware that it will really help. All right, let's take a look at one with both variables again. So remember how we talked about you can factor with both variables or variables in both positions. So we can take a look and see how that's going to look when we are doing something that doesn't have a leading coefficient of 1. All right, so first order of business, check for GCF. 6, 7, and 5 don't have any GCF, so I don't need to worry about that. We're going to go to our two binomials, and we'll start with our first. So let's take a look at the first. So the first need to have a product of 6. So we're trying to pick just some smaller numbers here. So again, things that multiply to 6, 1 and 6, 2 and 3. So we know it has to be one of those two pairs. M squared in these first positions means there's going to be an M and an M. All right, let's take a look at the last term. The last term is a 5n squared. So again, we have that n in both of those positions. So it's definitely going to be a something n times a something n. It's a negative number, so this product is supposed to multiply to a negative 5. All right, so there's only two things that multiply to 5. It's another prime number, which is great. It's just 1 times 5. But because it's negative, it's either going to be negative 1 times a positive 5 or positive 1 times a negative 5. Now, the best case scenario we can run into is if we get the right number, but just the wrong sign, because it's pretty easy to switch the signs. We just have to make sure we have the numbers in the right spot. So we want to make sure that that can happen. So let's see if we can find out some ways to do this. So I know the signs are going to be opposite. I'm just going to throw plus and minus in there then, just so I have them. And we're going to try some numbers. So I guess I'll say a plus 5 here and a minus 1 there. I don't know if it's going to be the signs actually flipped, but let's just put them in there. Again, it's only 1 and 5. There's no other choices for those spots, which does make this a little bit easier than the one that we finished up with yesterday in that day 1. Okay, so let's choose our weapon here. Which one do we want to go with? The 1 and the 6, the 2 and the 3. What are you feeling lucky with here? We only have to make a 7, so multiplying by 6 seems a little scary to me. We might be getting too big of a number there. Let's give the 2 and the 3 a whirl. So what if we put the 2 here and the 3 here? See if that works. And if that doesn't work, remember our other option would be putting the 3 with the 5 and then the 2 with the n. You don't need the 1, but if that helps you, just keep track. So let's give it a try, see what happens. For the outsides, for this first possibility, 2 times a negative 1 would be negative 2 mn. Insides looks like 5 times a 3, which would be a 15 mn. And when I add those together, it would be a 13 mn. So too big. So that's not going to be the pair that we want. All right, so we'll try it the other way. Outsides looks like that would give me a negative 3 mn. Insides looks like it gives me a positive 10 mn. And when I add negative 3 plus positive 10, oh, look, there we go. That's our 7 mn adds to positive 7. So these are the pairs that we want. Now, say I had put the signs in the opposite way. What if I had put the negative there and the plus there? Then I would have gotten a negative 7m, which is, like I said, the best possible issue to have, because all that would have meant is, oh, no, that one was really supposed to be the plus, and this one should have been the minus. So if you ever have that issue, like you get the right number, just the wrong sign, fantastic. Just flip your signs, and then you'll have your pairs that you need. So we have our 2 binomials. All right, last one I want to deal with is the idea of looking at if you have a negative leading coefficient. So I want to talk about that. Having a negative leading coefficient is really tricky because it's really hard for people to look at this and say, okay, what multiplies and starting off with a negative. I'm a very positive person. I like to get that out of there. So if you remember, we did this in some GCFs. I'm going to pull out a negative. Now, if there was any other number in common, I'd pull that out too, but there isn't. So I'm just going to pull out a negative 1. And again, this is just help my just being able to come up with these pairs. So negative 1 times what would give you negative 2p squared? Well, 2p squared. Negative 1 times what would give you negative 5p? Well, that would be plus 5p then, right? Negative times a positive. And then last one, negative 1 times what would give you a negative 12? Minus 12, because remember, a negative times a negative would be a positive. Now, why did I do that? Again, it's only so I can start with a 2p squared. Do you have to do that? No, not at all, but I think it's going to make your life a whole lot easier if you do. So if you have a leading coefficient that's negative, less than 0, factor out that negative 1. It's so much easier. So if we factor out the negative 1, then we don't have to deal with a negative value on the inside. So it's just going to be part of our final answer. So we'll have that negative 1, and then we're going to have our 2 binomials. So it's going to be the same process from that point on. So let's start with our different pairs here. So we're going to look for the first is a 2p squared. So we need a product of 2. We love 2. It's a prime. What's the only way to multiply to get a 2? 1 times 2. So in this first position, to get a 2p squared, I'm going to need a 2p and a 1p. In whichever order you want to put them, it's fine. That works out super great. For our last position here, so for the negative 12, we need a product of negative 12. Now, how do we multiply to get a negative? What do you know about your signs? The signs have to be opposite, right? So they have opposite signs. So that means one of them is going to be plus and one's going to be minus. I don't care right now. I'm just going to fill them in because I know they're going to have to be plus and minus. I can adjust if I need to. All right, what's going to go in the last position then are things that multiply to make 12. So 1 times 12, what's another one? 2 goes in there 6 times evenly, and then 3 times 4. So I have some options. I'm going to have to pick from this list and kind of guess and check and see what works, one of them being positive and one being negative. Ultimately, my insides and my outsides need to add to a positive 5. All right, so we got to try something. So let's make a choice here. See if we can come up with some numbers that work. 1 and 12 again seem pretty big. Multiplying by 12, if my middle term is only supposed to be 5, might be a little bit large. What do we want to try? Try pausing the video. Guess and check. See if you can come up with some things that might work. I think we got the 3 and the 4. I don't know which order to put them in here, but let's just give it a whirl and see if this works. So I'm going to plug in the 3 and the 4. Outsides. 2 times negative 4 would be negative 8. Insides would be a positive 3p. So negative 8 plus positive 3, ooh, that's negative 5p. That's super close. I wanted positive 5p. So how do I make that adjustment? Well, instead of the first term being the plus and the second one being the minus, I actually want the first term being the minus and the second one being the plus. That would give me a positive 8p, a negative 3p, and there's my positive 5. So I actually want 2p minus 3, and then 1p plus 4. And notice that negative 1 is still part of your factoring, because when I multiply this all back together, I need to multiply by that negative 1 to get back to that original. So definitely that leading coefficient not being 1, always more work. If it's negative, makes it more stressful. Pull the negative 1 out. This is just like, can you power through the guessing and checking? There's limited options. We just have to see what works.